Good morning, students. Today we are going to see about the projection of solids, which is coming under the third unit of your engineering graphics. So far we have seen the projection of points, projection of straight lines, and projection of planes, isn't it? So can you tell what would be the dimensions for a solid? How many dimensions are there for a solid? It's a little louder. 3 dimensions, right? So the planes have 2 dimensions, whereas the straight lines have 1 dimension. And the points, it is 0 dimensions, right? So now, any 3-dimensional object is said to be a solid. Okay, to understand the concept, the basic concepts and the techniques behind your engineering graphics, we need to have the basic or the standard set of solids in engineering graphics, right? So these solids can be classified into 3 types. One is prisms. Second one, pyramids. And third one, solids by revolution. So this is how we just classify the solids into 3 types. So first one is prism. So what do you mean by prism? See, for example, to take this object, so where we have 2 bases, right? So the upper and bottom surfaces are said to be the bases, and these sides are said to be a lateral surfaces. Okay, so bases and a lateral surface. This lateral surface in prisms and pyramids, they are said to be face. Okay. Can everyone understand what I am saying? So this is what. Now, when this object is having 2 bases, okay, then those type of solids are said to be prisms. And moreover, these 2 bases will have the same shape. So what is the shape of your base? What is the shape? So this solid can be called as a triangular prism. This solid can be called as a triangular prism. Okay. Now, so let us see this object. So what is, how many bases are there? How many bases are there? 2 bases. So definitely it can be called as a prism, isn't it? So now the shape of the bottom or top base, it is a square. So how we can call this solid? Square prism, right? So likewise, so this base is having a hexagonal pentagon. Pentagon. So how you can call this solid? Pentagonal prisms. So now you understood what is meant by a prism, right? So that is your first category. Okay. Second one is pyramid. So you can directly see the model of a pyramid, right? So can you able to identify the difference between the prism and a pyramid? How many bases are there for this pyramid? Only 1 base. Whereas on the other side, you have a short corner, isn't it? Okay, so that point is said to be apex. That point is said to be an apex, right? And now you can see, for example, this is a square prism, and this is said to be a square pyramid, right? So how many corners are there for this prism? How many corners? You already know about corners because already we have explained everything in planes, isn't it? So a square at the bottom base is having 4 corners. Similarly, the top is having 4 corners. So totally how many corners? 8 corners for a square prism, right? So 2 bases, 8 corners, and how many faces are there?
4 faces.
4 faces. 1, 2, 3, 4. The lateral surfaces are said to be faces. right? So 4 faces are there. So 2 bases, 4 faces, and then how many corners? 8 corners. So this is the nomenclature of a square prism. Whereas if you take a square pyramid, how many bases are there? Only 1 base. You have 1 apex. And how many lateral surfaces? That what we can call as face. 4. So here also we have 4 faces. So what is the difference you observe between these 2 solids? So here also we have 4. Okay, here we have 4. And moreover here we have 8 corners, whereas here we have 4 or 5. 5 corners. 4 at the bottom and 1 at the top. Can you able to understand? Right? But regarding to these faces, we have 4 faces here. Similarly, the pyramid is also having a square pyramid is also having 4 faces. But what difference you observe? So that's why we have to go for another nomenclature, that is our terminology, edges. Right? So 1, 2, 3, 4. These 4 edges are said to be base edges. Okay? Whereas these 4 edges are said to be lateral edges. Okay? Can you able to understand? So what do you mean by base edge and what do you mean by the lateral edges? Okay? Are the edges of the face. You can see. Here, these edges are vertical. These edges are vertical. Whereas in the pyramid, here also we have 4 lateral edges, but those are slanting. So that is why in pyramid we call these edges as slant edges. These edges as slant edges. Can you understand? So this is what. So these slant edges connect the corners of the base and the apex or the topmost corner. And here, this vertical edges will connect, vertical lateral edges will connect the opposite corners of the bases. So suppose you mark this as 1, 2, 3, 4 and this as P, Q, R, S, then the corner 1 will connect to what? Corner P. Okay, so straightly it will be connected. So those will be the vertical edges. So this is how we see the difference between the prisms and the pyramids. So with these details only, the problems will be asked, and we have to think about, suppose they say square pyramid is resting on HP, that is horizontal plane, and is resting with one of its corner. That means that one of its base corner, it means how many corners are there? 4 corners. 4 corners at the base. So it is going to rest with one of the base corner like this. Okay, and when it is resting with the corner, definitely the slant edge would be inclined to a horizontal plane. Am I right or not? Whereas when it is resting with the base edges like this or this, there definitely the surface, that is the lateral surface, will incline to HP or VP. So like that, we have to identify, we have to think. Can you able to understand? Just so this age is imaginations and creativity. So according to the problem, according to the inclinations of various things. And moreover, the very, very important thing in doing this solids, position of solids, is the axis. So axis is a very, very important phenomenon. Whereas in the planes or in the straight lines, do we have any axis? We don't have any axis. Am I right or not? But in solids, we are mainly concentrating on the axis. So what do you mean by an axis? An imaginary line, right? Axis is going to be an imaginary line. It's not like your other edges. These edges are real. You are able to see, isn't it? Whereas the axis are not able to see, but we are assuming imaginarily, okay, which is assumed to pass through the midpoints, pass through the mid portion of the bases. Suppose if it is a prism, right? So you take the there is a mid position or the center points of both the bases, and you just draw a line which is connecting these center points, so that that line, what you are going to draw, is going to be the axis. Can you understand? And how you will denote the axis of this pyramid? It is having only one base. Definitely it is going to have a center, isn't it? Because it is a regular polygon. Okay. So the center is marked and there is an apex, isn't it? There is an apex. So when the line joins the center part of the base and the apex, that line is said to be what? The axis of the pyramids. Can you able to understand? So how do you draw or how do you denote the axis of these solids? Can you able to understand? So have you understood the terminology of these solids? That is pyramids and the prisms. Yes? Now, the third category, that is solids by revolutions. Okay? See, as unlike your prisms and pyramids, you don't have any sharp edges. Sharp edges, or you will not have any sharp corners. Okay, but in prisms and pyramids, you have sharp corners, you have sharp edges. Whereas this solids by revolution will not have any sharp edges or sharp corners. For example, you take a cylinder. I'm just drawing the front view and the top view of the cylinder. Roughly, not as per the engineering standard, just to understand. So when you observe from the top, it is going to be a circle. Okay, so do you observe any sharp corners? No. Similarly, on the lateral surfaces, so it is totally, it is a curvilinear surface, isn't it? So it is a curved surface. So we don't able to see any sharp edges. Am I right or not? So that is why this is said to be solids by revolution. Why this word revolution comes here? Say to attain the cylinder. For example, this cylinder is of diameter say 50 mm, right? And say height as 60 mm. So what would be its radius? So definitely its axis is going to be at the center, right? What would be its radius? If it is 50 mm diameter, what would be its radius? 25. So I'm just taking the x-axis and y-axis, that is two reference axes. You take a rectangular lamina. You take a rectangular lamina of say width 25 and height 60. And about this y-axis, you just rotate this lamina. About the y-axis, keeping one end fixed, you just rotate this lamina, rectangular lamina. Okay, what happens? Definitely, it will sweep a cylinder, isn't it? So that is why by revolution the solids are got, isn't it? So that is why it is said to be solids by revolutions. So similarly, how you will get a cone? You take a rectangular and triangular lamina, and a similar way about this y-axis, you just revolve it. So what happens? Automatically it will sweep a cone. Okay, is it clear? And when you want to get the another solid by revolution, that is a sphere, right? You take a heavy sphere and you just revolve it, you just do revolution. What happens? You sweep a sphere. Is that clear with this? Any doubts? So this is how the cylinders, cones and these spheres are being obtained by just revolving about any axis, say x-axis or y-axis, whatever may be the axis, but just by revolutions we are going to get. So that is why these solids are said to be solids by revolutions. Any doubt? So these are the standard set of solids which we are going to see in our engineering graphics. and their relative positions with respect to horizontal plane, vertical plane, their inclination of their axis with respect to horizontal plane, vertical plane, and all those things has to be identified, and according to that the view, the front view and the top view, and the final front view and top view has to be outlined. Okay? Yes, take note. Draw the simple position of a square pyramid which is resting on horizontal plane, with its base having its base edge inclined at a 35 degree to VP, and the axis perpendicular to HP. Draw only the simple position where, see what I told, it is going to be a square pyramid or triangular pyramid? It is a square pyramid. So this is a square pyramid. Do you agree? Because this is a pyramid because we have only one base, and the base is observed to be a square. So definitely it is going to be a square pyramid, right? So this square pyramid is going to rest on horizontal plane. And what the next question they are saying? Yes, let us draw the position of the solid according to the problem. So this is going to be a square pyramid with the base edge, with the base side 30 mm and the height 60 mm, isn't it? And we are going to make one of the base edge inclined at 35 degree to VP. And this axis is going to be perpendicular to HP. That means that what would be its position? It would be, this position is the axis perpendicular to horizontal plane, whereas slightly if we incline this edge 35 degree to VP. So this inclination can be absorbed only in the top. Am I right? So we'll start with this. So let us draw the reference line. Draw another line using H pencil to an angle of 35 degree, where the one of the base edge is going to rest. Now, what is the base side? Yes. What is the base? Length of the base? It is 30 mm, isn't it? So you mark 30 mm. Somewhere else along this line, because they have not mentioned the nearer corner is how much distance from the vertical plane. So somewhere else you just roughly mark conveniently, so that you have to mark the corners, so leave some space. So conveniently you just mark this 30 mm and try to complete this square using your instruments. Yes, listen here. Actually here we have drawn the top view, so when you observe, you can be able to see the plane. Isn't it? And what all you will observe? Yes, you have an apex, right? And there are slant edges, right? How many slant edges are there? How many slant edges are there? 4 slant edges. So these 4 slant edges it seems to be starting from this apex and ending at what? The base corners. Am I right or not? So now, when you observe this, these slant edges would be visible or not? Is it visible? Is it visible? But not to the true length, but of diminished length. But there it seems to be a line which connects this base corners and the apex. Okay, so when you draw the pyramid, you have to draw the slant edges also. Now we have to denote the corners. So let us say the base corners are A, B, C, D, and the apex. So we will just mark the top corner as O. So this is going to be your top view. So don't darken anything. So finally you can darken it. Now we have to draw the front view for this. Yes, listen 1 second. So to draw the front view of this, we have to project all the corners up to this reference line as we did before, isn't it? So now you just project all this using your draft scale so that it should be all these position lines should be perpendicular to your reference line. And project all these corners like A, from A, O, C, B. Okay, so before you just draw the front view, what is the height of the solid? Height of this square pyramid? 60 mm. So this 60 mm denotes the axis height. Is it right or not? So when you say the height of the solid is 60 mm, that means that the 60 mm denotes the height of this pyramid. Okay, not this slant edges. Okay, in case of pyramid. So this is what the projection from this axis, apex O. So you just extend this line up to 60 mm so that this point is going to be O dash, which denotes the top corner of the apex in the front view. And mark out all these bottom corners. So the line which is projected from this A, this is A dash, this is B dash, this point is C dash, and this is going to be D dash. Right? Now you just connect all these corners, all the bottom corners to the top corner. Simultaneously just mark down the dimensions also, which is very important. So 30 is your base side and 60 is your height. Now you tell me, when you observe from the front, listen here, when you observe from the front, what are the slant edges that would be visible? For example, I am saying this is O, this is A, B, C, and D. According to our diagram, this A, D, B are in front, isn't it? Am I right or not? Yes, 1 second, all of you listen here. When you observe from the front, this D, A, B, all these bottom corners can be observed, visible or not. Yes, so this D, this A, this B, all are visible. So the position is like this. After making inclination of the base edge 35 degree to VP. So how many slant edges are visible? How many slant edges are visible? Yes, for this side. So 1, 2, then 3. Is that clear? So when you observe in the front, so 1, 2, 3, these three slant edges will be visible. Or from this diagram you can easily understand this C is just behind this plane. So you can darken this OD, OB and this OA. This OC is just behind this, okay, behind this, so it is invisible but it is hidden. So you have to show this slant edge with the hidden line. So what you will make hidden line? The hidden line is a discontinuous line. Okay, so this line will indicate that there is an edge but it is hidden at the back side. Right? And definitely the base would be visible. So when you observe, so these bases will also seem to be a straight line when you observe in front. So this base has to be dark. And don't forget to denote the axis line, which is very, very important. And finally, you just darken the top view also, where you can be able to see the base edges and all the slant edges like AO, BO, CO and DO